So what I want to do here, Alright, so I want to basically say if the ID of this ID equals this ID, and then we want to do an AND. Let's see, we want to not equals for integers. Actually, yeah, I'll have does not equal -1. And then we'll do a branch here. Alright, if this is true, then we need to go do logic stuff. So let's give ourselves some more room. And let's also make sure that this stuff actually compiles, because we were getting some issues with some reference stuff, and I want to clear that up before we do a whole bunch of other crap, just in case we have to go change stuff. He's trying to make the mushrooms glow, so probably a point light would be the best thing for that, but it's going to light the mushroom then, right? So if you want the mushroom to glow, like, you can do emissive maps on it, but then it won't affect the environment. But if you do a point light, it's going to have it's going to light the mushroom itself, and the mushroom might look a little weird, right? Because it needs to light, it needs to appear as if the glow comes from the glowy bits on your glowing mushroom, right? So it could be some post-process blur, or post-process effects with that stuff could do it. Or you could have a whole bunch of point lights that are, like, you have an emissive layer on the mushroom, and then you add point lights, but you add them so they affect the environment, but they're far enough away from the mushroom where they don't actually cast light on the mushroom. So you have to kind of fake all that crap, I think. Anyway, so this compiles now, which is good. I think it was just that it wasn't a blueprint type, so it was getting all confused beforehand. Alright, so what we should be doing is basically, if we are awaiting jump, the jump in, alright, so I need to set awaiting jump anim to, actually I could just, I don't need awaiting jump anim. What I need is, we're going to get the jump animation ID, and we are going to get an equals with an integer, and if this equals -1, let's get a not equals. Not equal. So this is basically, if we are awaiting a jump anim right here, then we won't do anything. Otherwise, we will do that. We'll set this jump animation ID and all that stuff here. So then over here, if the current animation, we have to do a few things, don't we? So if the ID here does not equal, okay, so we have plenty of things. The first thing is going to be if the jump animation ID is not equal to -1. So if the jump animation is not equal to -1, then we're going to do stuff, otherwise we're going to get out of here. So let's make a reroute node right here, which is going to feed into here. So if this thing is, let's actually use an equals gate here. Alright, so if this is -1, then we just continue forward. So we are not waiting for a jump animation to play or anything else. Then we're good to go. Okay, so this is not -1, so we can remove this and all that stuff. So we're going to get the current animation state that we're in, and we need to handle the error cases. Alright, so we'll grab the current animation state and its ID and all that off of it. And we need to say if they are not equal, then we need to break out, because like if the animation playing is not the animation we're waiting to finish, then we need something change the animation on us, and we need to reset our jump animation ID and not do anything. So we need to say not equals. So if they are not equal, then we're going to need to set this jump animation ID to -1. And get out. Otherwise, what we need to do is we need to check if the animation is finished, basically, if we're ready to jump. Alright, so we know they're there. Okay, so I need to get the current animation stuff. So what do we have in our animation controller component? We've got I think we need get %finished is what we want. No, we don't want get %finished. We want the get current playtime and get animation duration. So get current playtime and get current animation. Get animation duration. Let's see. Get animation duration. Let's. I'm gonna double check exactly what the definition of that is. Okay, so it's the duration of the current state. So that should be correct. And let's look at the playtime real quick. Let's verify that it's what we think it is. It's gonna get the game time and minus the current state start time. So the start time is gonna be when we call clear on it. Doesn't seem like this current playtime stuff is actually going to work properly for us. Yeah, we're not even using that start time stuff is what it looks like. We should probably just be using the flipbook component directly. So we want to call get playback position and get flipbook length. And that'll give us where this is going, and we need the... How do we know how much time is accumulated in the... I guess this is correct, like this is in seconds. So we're not actually going to be... We don't want to grab it off of the flipbook, we want the flipbook component. There it is, get flipbook component is something we can actually do. Alright. So we want to call get playback position, and we also want to call get flipbook length. Now how come these are green and this is blue? I should look at that real quick, because the problem here is I have to pass an exec through this to get this, which means I have to route more crap through. If I don't have to do that, maybe there's something I'm doing wrong here in blueprints where I don't have to route stuff all over the place. Let's go to the paper flipbook component. And let's look at the get playback position. It's blueprint callable. Yeah, I do not know why the if it's not a static function. Is it because it's const? It must be because it's const that there's some sort of pre-compute stuff going on there. So that's something I should actually remember. Why don't I just like write that down in my notes? If you make a blueprint callable method const, you don't have to exec through the node when calling it. So that's pretty cool. So what that probably means is if you put const on one of your blueprint functions, that it's going to call this function as soon as the variable is set properly, and kind of it can actually reverse engineer if your stuff is going to call it or not, and then it'll kind of work like C or something and like call these functions at the beginning and then fill them out later for you. So that's cool to remember in case I ever need to look at that, because then we don't have to worry about all this stuff. Alright, so we'll get the playback position and flipbook length, and I want to add the current dt, so I need the jump function to actually take the current delta t, or do I? Let's look. The event graph for this thing, this is our update. We're actually setting the current delta t. So we already have the current delta t. I can just look at this. So let's see, this playback position and current delta t. Let's verify that the paper flipbook component so the accumulated time is, we just want to make sure the accumulated time is being set in So when it calls tick, the accumulated time plus effective delta time, we have play rate. Okay, so we need to actually get the play rate as well. We need to multiply the play rate by this, yeah. Get playback position, and is there a get play rate? Yeah, so we need to get the play rate. And what is... Play rate is a float, and reverse playback is something entirely separated from play rate, so it won't be negative. And so we need to do a multiply of the play rate. By delta t. And then we basically want to do an add. So we're going to add our current playback position to our... Basically, this is how much it's going to go this frame, and this is the length. And if we add them together and if we do greater... then that means we're going to jump this frame. Alright, so... So if this is true, then we will be able to jump this frame. So we can actually set like a local variable here, which we're gonna have be a boolean, which we'll call it can jump this frame, and it's gonna be initialized to false, and we're gonna set it to true here. And we gotta reorganize all this shit. Alright, so can jump this frame will be true, and we'll want to unlock the animation stuff. We also want to set this jump animation thing to -1. Alright, so we need to change the lock. Where is the lock? Yeah, here it is. All of this stuff just is getting too big. Alright, so what this is going to do is on that, then can jump this frame is going to be set to true, and what we want to do over here is man, okay. We need another case here. The other case is that we are no longer on the ground. So let's see, do we have A pressed and then we're not on the ground? We have a lot of logic mixed in here. So I actually need another one in here. Alright, so we need movement. So it's like get physics state, and then we need like switch on physics state. If it's in the air or none, yeah. This is where writing the code in C++ would probably actually be a little easier than doing it in all this node stuff. But I need practice writing more complex logic out in blueprints, I think, so. And knowing kind of how to do it. So it should look somewhat like this. We should OR together. It's like if we're not on the ground or the animation is different. So somebody interrupted us, basically. Then we should kill our animation ID, unlock the animation, and all that sort of stuff. So that's good there. Now we need to actually check over here. So right now we're not going to jump, and we're not going to have our want to jump stuff either. Alright. So if we get to here, then we need more room. If you get to this part, basically what we want to do is see if we can lock the animation. But if we can jump right here, if can jump this frame is true, then we can just go ahead and go to the jump logic. And if it's false, then we'll do like the whole like try to jump stuff. And our want to jump stuff is going to be a little bit crazy town over here. Because our want to jump actually needs to come down here, so this like if the return value is false, we go there, otherwise I guess maybe we need to call can jump. Alright, well this should work, so let's just verify that this works for jumping real quick. Well, we at least is our lock animation not taking? Alright, well why don't we just figure out our jump stuff first. So we'll throw a breakpoint in there. Playback position is 0. Delta T multiplied by it. What the hell? The flipbook length is 0.166? Oh, that's absolutely wrong. Alright, so something's going on with my logic here. Bitey's broken? What do you mean Bitey's broken? Which Bitey? The current Bitey? He's, of course, broken. Alright, so the play rate is 0.166. The accumulated time is 0. We're looking for the flipbook length. So it's source flipbook get total duration. Right, so paper flipbook CP get total duration. So it's num frames divided by frames per second. So source flipbook, let's see, frames per second is 60 and number of frames is 10. So what should be going on here is so it's what? So that should be our play rate. So that's the correct play rate, and that is also supposed to be our duration because we set it to 1 second, so it should be 0.166. Alright, so the playback position is the playback position multiplied by the play rate. So I need to like multiply this also by the play rate. So let's look at the get playback position. What's the accumulated time? The accumulated time is multiplied by the play rate. So, God, ugh. Annoying. So I need to do another multiply here where we multiply the play rate by the playback position. Like so, and that will actually set our stuff up. What? Alright, what's going on is this value is this. This value needs to be... I've got these mixed up. It should be like this. Alright, so that's actually going to set that. So let's make sure that that runs correctly. So let's see. It's getting stuck here. So why is that? It's because the current value is 0.03 and the necessary value is 0.16. Alright, so the playback position is 0.166. Okay, so that's correct. Okay, so I don't need to multiply the play rate by the playback position. It's already multiplied out. I just had my condition wrong. Alright, so that should set. So he goes into his thing. Alright, so we actually need to ignore all of this stuff. Like, if you can jump this frame, you should just go into the jump thing. So this whole box of stuff here should be done like immediately. It'd be like, well, okay, if we can jump this frame, that means we already hit the key and we did all that crazy stuff. Otherwise, we need to check if we can, tap keys. So if we can jump this frame, jump. I just love that tiny jump. Alright. Alright, so now we need to solve the wanting to jump problem. The wanting to jump thing should actually trigger one of these here. And basically the want to jump is not supposed to be set over here, it needs to be set basically if you're in the air is what we should be looking at. So if we're not on ground, then we want to set this. Alright, so we are not on the ground, so we'll do that. And if we are on the ground, then we'll try to do our jump move. Alright, let's see if this does what we want. Well, I think we screwed up wall jumping. So we have like a whole nother wall jump thing. Yeah. Alright, so if we are on the ground, we need to reorganize all of this garbage. Adam's done working for today. He's gonna go play some games. All right. Well, I'm working on the jump logic. Basically, at the moment, I'm overhauling it so we have the jump animation before we actually jump, and I'm having to do a whole bunch of stuff to fix it. So it's basically if we are not on the ground, we're actually just gonna call jump directly, I think. Dead cells as usual. Yeah, that makes sense. Alright, so this is going to be the air. This will be the wall jump if it actually happens. Alright, so if this condition is false, then we're going to set 1 to jump to true. And this true needs to go up to this if else gate. Ugh, kind of copy paste in Blueprint is kind of massive. Alright, so I think maybe this won't break wall jumping. But we're going to have to take a look at that. Alright, so let's run through it real quick in our heads. So if we can jump this frame, that means that we actually finished our jumping animation, and we're going to go try to jump immediately. And then we're done. Otherwise, we're going to look at the keys. So if the A action is triggered, and the left stick down is not pressed, and wants to jump is true. So yeah, okay, one of those two. If that is true, then we're going to see if we're on the ground. And if we are on the ground, if we are not on the ground, then we're going to just go ahead and try to jump, which will be a wall jump if it succeeds. And if it fails, we're going to set our wanting to jump intention. So if we are on the ground, we are going to see if our jump animation ID, so if we're already trying to jump, then just go ahead. We've got our intention set. Otherwise, start our jump animation, which is stationary jump. Alright. And let's go make sure we can actually wall jump. And we'll change that stationary jump to a different jump depending upon our... Yeah, okay. So we can totally wall jump now. Cool. Alright, it doesn't look like the jump grace period is being set properly. So let's look at that. If we want to jump is true, then jump grace period minus equals and set it. It's 0.1. Alright, well, let's debug that real quick. So let's throw a breakpoint right there. What is this logic here? It's okay, so we're decrementing the jump grace countdown by current delta t, and then we're seeing if the current delta t is, if the jump grace countdown is less than the current delta t. Shouldn't it just be like if the jump grace countdown is less than 0, then want to jump should be false? Yeah, okay, that was kind of an odd choice I had in there. Something that could have worked. Alright, so set want to jump to false. The wants to jump is getting reset every single time. So, wants to jump should be only reset if wants to jump is false. Alright, so I'm going to leave that the way it was. There's probably a reason I had it like that. I can understand why I would do something like that. But this basically is, we need a condition here. If wants to jump, we need an and. Let me see, it's, no, this is not correct. We need to and, yeah, okay. It's an and key triggered. Alright, so it's when you grab the controller and be like, okay, did you actually hit the key this turn to do this? And if you did, then we can do it. Okay. Lots of little things. Alright, so what we want here is this. This is like, well, oh no. Giant spider web. So basically what this is doing, guys, just look at all that garbage. Jesus Christ. That, like, all those lines converging. So let's do a Boolean not. Just to make this a little bit easier to read. So it's basically if we tried to jump and then we couldn't jump, we're gonna check if the A key was triggered this frame. If the A key was triggered, we don't want triggered, we want held, don't we? Well, this is a question actually. So if I hold down the A key and then I press it again and hold it, do I want to jump as soon as I hit the ground? So I think it's just triggered. So triggered would mean like if I hold down the A key and then I'm in the air and then I hit the A key and I hold it down. If I keep it held, as soon as I hit the ground, I would jump. Otherwise, it's only going to do triggered. I think I just want triggered. So you only jump if you actually started holding the A key recently. In case, somebody like is holding down jump. I can cause, extra jumps. Alright, that's feeling correct. Let's make sure we can still wall jump. Alright, so let's try this with a much faster jump animation. Let's try playing this at... He's got 10 frames. 10 frames of jump. So why don't we do it in... like at 60 FPS. 10 frames would be... it's like 0.016 times 10. So we should do 0.16 seconds. I mean, you'd think I'd be able to multiply 10 by, 16 in my head, but that's not how I roll. I have machines to think for me. So what's going on there is it looks like there's one frame that's having problems there. It's the frame that basically what's happening is the logic is updating and then the post move is happening and the post move is saying, well, you're still on the ground. Right, well, let me just see which order everything's getting called in here, because what I think's happening is like something is detecting that it can actually change the state. So we need to go into bitey movement. Let's see which state is actually changing this. So if we go to our entity, which dude is actually, it's this dash idle is what's going on. Okay, so we need to go into the dash state for movement, which is here. So it's on post update, blah. So the question is, when are we transitioning to the in-air state? Is that just in our movement controller? So on post update, we should be transitioning to the in-air state and setting the next movement state to it. So the question is, when does the state transition happen? The state transition happens, I believe, inside of the movement object. Sorry, so we have set next wanted state. And then transition to wanted state happens pre-update and update. So it happens after this thing.